So this video is the first in our series on predicting products, and this is predicting the products of single replacement reactions. So a quick review of single replacement reactions. Remember that single replacement reactions are the steal your boyfriend, steal your girlfriend reactions, and they look like this. Remembering that a compound plus either a single element or diatomic gas will give you a new compound and another free element or diatomic gas. Of course, remember these order right here is flipped because it depends on whether this forms a cation or an anion. Remember, this is always a cation. This is always an anion. So if this is a cation, or if this is an anion, the situation is the first one. If this is a cation, the situation is the second one. And it's the general format. AB plus C gives you either AC plus B or CB plus A. The thing about single replacement reactions is they don't actually always happen. Single replacement reactions are governed by something called the activity series. And what the activity series does is it compares how reactive that free element or that free diatomic gas is compared to the one it's going to replace in the compound. So let's draw this out. So here we have the reaction of the compound gold-green plus blue. In this case, let's say that obviously gold is the cation and green is the anion. Let's say that blue is the cation. So there are two situations here. There's a situation which says if blue is more reactive than gold, and there's a situation which says if blue is less reactive than gold. And we'll draw that down here. So if blue is less reactive than gold. So if blue is more reactive than gold, blue wants to be in the compound more than gold. So what happens is blue and gold are going to swap places, and you'll get the new compound, blue-green, plus gold, and gold is on its own. You can actually think of this as, if this is the steal your boyfriend, steal your girlfriend reaction, as blue being more attractive to green than gold is. But if blue is less reactive than gold, blue and gold can't swap places, and no reaction will occur. So as I said before, whether or not the reaction can occur is governed by this chart called the activity series. And you're going to be given the activity series, so it's not something you have to memorize. In fact, the sub has a copy of this for you if you want to go get it right now, so you have it to look at. But basically, we have the activity series for the cations, which are over here on the left, and we have the activity series for the anions, which is over here on the right. There's not a lot of anions. It's really just halogens that would be the anion. But the idea here is the higher something is on the chart, the more reactive it is and can do the replacing. So for example, if you have a compound with potassium in it, potassium is right here, potassium is very, very reactive. Therefore, the only thing that could replace potassium would be free lithium, which is a little bit more reactive. And it just kind of goes like this. Same thing with the halogens. For example, if you have a compound with bromine in it, if free chlorine or free fluorine gas are available, they'll replace it, but iodine won't. So let's look at a couple practice problems and see if the replacement will happen. So here are 4 reactions, and let's figure out whether or not replacement is going to happen. The first one is zinc and hydrochloric acid. So here's what I do. I have to look at zinc first, and I see that zinc is a metal. Remember that metals form cations, so just to make a note, I'm going to put a plus above it just so we know. And then I've got to look at my compound. In this I have H and I have chlorine. Chlorine is the anion, hydrogen is the cation. So then I go to my chart and I'm going to try to find them. I'm going to compare zinc and chlorine. Zinc is here. I'm sorry, zinc and hydrogen. Zinc is here, hydrogen is here. Zinc is higher than hydrogen, so the reaction will occur. This is a yes. Let's look at the second one. This time my free atom, which I look at first, is nickel. Nickel is a metal, so it's going to get a plus for the cation. Then I look at my compound. We have the cation of aluminum. We have the anion of oxide. Aluminum will have to be replaced by nickel. So I go find nickel. Nickel is here. Aluminum is actually up here. Let me do that one in red so you can see it. But aluminum is higher than nickel. Nickel is not as reactive as aluminum. Nickel cannot replace aluminum because it's lower on the chart. So this one is a no, it won't react. This third one is tricky. I'll do it in blue. Remember, we look at the free thing first. This is magnesium. It's going to be a cation because it's a metal, so we'll put a plus above it. Whenever you see H2O, you need to think of it, instead of being a covalent compound of water, you need to think of it as the compound HOH, or hydrogen hydroxide. Every time for water. It's the only tricky one. H is the cation, it's the plus, so magnesium is going to replace hydrogen. Magnesium is here, hydrogen is down here, so this reaction will occur. And we'll talk about how to do it later, but whenever you have signal replacement with water, think of water as the compound HOH. It'll make it easier. Finally, this last one. This time my free atom is bromine. Bromine is a halogen, so it's going to form an anion. KCl, K is positive, Cl is the minus. We go to the chart. Here's bromine, here's chlorine. Chlorine is higher than bromine, which means chlorine is more reactive than bromine, which means bromine cannot replace it. So now that you have seen how to figure out whether or not the signal replacement reaction will actually occur, you need to be able to write the products. In this case, there are always two products. The first product is the new compound, so the new two elements that combine. You're going to have to use the rules for ionic bonding to figure out the subscripts on the formula. And we'll do a couple practice ones, and there's a practice worksheet to show you. The second product is a new free element. The basic rule of thumb here is if the new free element is a metal, it's just going to be the metal in its solid version, so there's no subscripts or anything you have to write. If the new free element is a diatomic gas or a nonmetal, so it's one of those four diatomics or hydrogen, you're going to have to make sure it's a diatomic, in which case it has a 2 as a subscript on the element. I want to put a side note in for the 7 diatomic gases. Remember, diatomic gases are gases, and they're elements that are made of 2 atoms. Basically what the 7 diatomic gases are 7 elements that are never found uncombined in nature. And these elements, when you have them, are always gases. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, there's a couple ways you can remember it. You do have to have these memorized. The first is a pattern called H7. If you look at the periodic table, you have hydrogen all the way up here, and the other gases are actually over here, and they form the pattern of a 7. So you have, and I drew this kind of lousy, but you get the idea. You have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So that's one way to remember it. The other way is through this acronym that I don't love as much. It's called Dr. Brinkelhoff, with Br for bromine, I for iodine, N for nitrogen, Cl for chlorine, and then H, O, and F. These are all your elements right here with the capital letters Br, B, I, N, C, H, O, and F. But either way you can remember it, that's 2 ways to remember it. Just know that if you ever write these elements, you will never write O by itself, it's always O2. You will never write H by itself, it's always H2. You'll never write F by itself, it's always F2, because these gases are always diatomic when you find them in nature. So here are 4 problems, and let's practice predicting them. All right, we're going to start with the first one, MgPO4, magnesium phosphate, and potassium metal. Potassium is the anion, so we'll replace Mg. We go to our chart, potassium is here, Mg is here, potassium will replace Mg. This means that potassium and Mg are going to switch places. Potassium is right here. It's got a +1 charge. It's going to go with phosphate. It's a polyatomic ion, so we'll put in parentheses to make sure. Phosphate has a -3 charge. So when I cross this out, what I'm going to end up with, and I'll erase this because it's probably easier to do it that way, is I'm going to end up with a compound potassium phosphate, which is K3PO4. And then I'm going to have just magnesium by itself. Magnesium is a solid metal. Of course, after I'm done, I'm going to draw the arrow to show the reaction happened. After I'm done, I'm going to go back through and balance it, which means there would need to be a 2 here, a 3 here, and a 6 here. Okay, let's look at the second one, H2O, and iron. We'll do this one in blue. Remember to think of this as HOH. Fe is the plus, H is a plus. I go to my chart. Fe is higher than H, so this reaction will happen. So now Fe is going to replace the H. In this case, we have Fe and OH. What we don't know, though, is Fe is either a +2 or +3 transition metal. I'd have to tell you. Let's assume it's +2. OH is -1, which means when we crisscross our applesauce, we are left with Fe OH2, and then hydrogen by itself. But remember, hydrogen is one of those diatomic gases, and it can't be by itself, so it needs a 2. And then we're going to go back and balance it. In this case, all you got to do is put a 2 on the water, and the whole thing is balanced. All right, let's do the third one. We'll do this one in red. F2 is the free one. It's going to be an anion. It's going to replace bromine. F is higher than Br, so F will replace bromine. So we have Ca bonded to F. Ca is a 2+, F is a -1. When I crisscross, what I'm left with is the compound CaF2. And then I'm left with Br by itself, but Br is also one of those diatomic gases, so it gets a 2. And then this is already balanced for me. I don't have to balance it. Finally, this last one, let's do it in green. Pb is a metal, so it's an anion. It's going to replace Ca. I find Pb, it's here. I find Ca, it's here. Ca is actually higher than Pb, so in this case, there is no reaction that's going to occur from this problem. So the best advice I can give you on these problems is to practice, practice, practice. You need to first figure out whether the reaction is going to occur. Then you're going to need to make sure you know how to write the formula for ionic compounds to make sure you can write the formula for the new compound correctly. Then you're going to be tripped up by making sure that you have the diatomic gas correct. And then finally, you've got to go through balancing the whole thing. So there are really 4 steps to these problems. The more practice you can do, the better. And as always, you can keep watching this video over and over again if you need help. The sub has a worksheet for you to practice, and when you've finished, I've included an answer key for the worksheet in Schoology.